All right. Okay. Yeah. Thank you, everyone, for being here. In this talk, I'll be talking a little bit about student engagement. So that's basically a topic that's becoming increasingly critical, especially with COVID, as education has evolved into a digital and hybrid format. So this work is presenting preliminary joint work with my PhD student, Laura Johnston. So we're all aware, basically, that we now have an unprecedented amount of data available to us through VLEs or virtual learning environments. And while this data offers immense potential, we actually need some systematic methods or methodical approaches to turn the raw features that we have from such environments into actionable insights, or actually proactive metrics that could help us better understand and improve student engagement. So the focus on student engagement is actually something that literature agrees on. It's a key driver of learning outcomes and student success. And actually, even the best educational content will fall flat if there is no engagement from students. So it's really something that matters and that we need to know how to measure, especially in online settings. So let's begin by defining student engagement. The term is actually so widely used that it's become hard to pin it down. Gibbs aptly described it as being used to refer to so many different things that it's difficult to keep track of. And then Crowe also similarly called it a catch-all term. Basically, it describes a variety of behavior, and then she comes down to describing it as the time, the energy, and the resources that students devote to the learning activities. Fredericks, Blumenfeld, and Paris broke it down further into 3 dimensions. So the behavioral, the emotional, and the cognitive dimension. And each of these dimensions contributes to a more comprehensive understanding of how students interact and benefit from their educational experience. So if we take a closer look at these dimensions, we have the emotional engagement which involves feelings of belonging and connection. This is mostly about whether students feel part of the learning community. And then the cognitive engagement, which reflects the mental investment students make in understanding. So here we can, for example, talk about Kolb's learning strategies or learning behaviors, whether we have a deep learner, a surface learner, or a strategic learner. And then behavioral engagement, which I am interested in today, is actually perhaps the most visible one. It includes class participation, completing assignments, following rules, and that's what actually Fredericks, Blumenfeld, and Paris said at the end. So they really narrowed it down into doing the work and just following the rules. And then we have some researchers like Young and others who actually emphasized on social engagement, collaborative engagement as other engagement aspects in online learning contexts. So why engagement matters, very briefly, it's been primarily linked to positive learning outcomes. Research consistently shows that engaged students achieve more academically and they develop more critical thinking skills. We have also, what's important maybe here as well, is that it affects student retention. And it's one of the strongest predictors of whether a student will persist in their studies. We also have some effect on equity in education from the research as well. So if we foster engagement, we can help close achievement gaps and basically ensuring that all students, regardless of the background, have an opportunity to succeed. So measuring engagement has not been very straightforward, although there are well-established methods in the literature. So these include self-reported surveys, they include teacher ratings, they include observational data, and each of these have its strengths, but they will be rather subjective. So, for example, self-report surveys will be accessible and scalable, but they will be prone to bias and subjectivity. We have similarly for teacher ratings or observational methods. The complexity becomes even greater in online settings because we have engagement that is not just about physical presence, but it's also about digital interaction patterns. And that's where learning analytics comes into play here. So the online engagement, whether it's fully online or hybrid, will introduce unique challenges and opportunities, but also allows for flexibility. That's why we are interested in online engagement here. So it has been proved that it's highly associated with higher attrition rates, as denoted by Meyer and Thompson. And to measure online engagement for you, methods were proposed in the literature. So learning analytics, there's also an increasing interest in eye tracking technology to gain insight into attention and focus. Then we have biometric data, which could capture, for example, physiological indicators of engagement, and natural language processing techniques, for example, to analyze discussion forums or written submissions. So all of this opens the door to richer insights, but we have to keep in mind that they come with ethical considerations about privacy and data use. Now, the work we've done actually focuses on leveraging data from Moodle to develop a reliable and objective metric for quantifying student engagement. So I'll go back to what Friedrichs, Blumenfeld, and Paris said, or a definition of behavioral engagement, and that's doing the work and following the rules. So this is a concept we really operationalize in our work through activity log data. So specifically, we will use metrics such as the page views, the content access, the assignments, submissions, to try and objectively capture engagement behaviors or online engagement behaviors of students. The key objective of the work is to derive and really investigate a signal metric for behavioral online engagement and investigate the reliability, basically ensuring that it is or it can serve as a foundation for predictive analytics in educational contexts. Then the metric here will aim to capture engagement in a way that it is interpretable and actionable to try and connect student behaviors with the learning outcomes more effectively. And this aligns with the growing body of research, which we will be starting from. So we choose a metric that has been developed by Wang and Chong, who extended the RFM, what is called an RFM model that's originally inspired from a marketing segmentation tool of customer behavior to the educational domain. So this metric captures multiple dimensions of customer behavior or student behavior, if you want. The immediacy, which measures the time lapse between the start time and the first access of a resource. And then the first or frequency one, which is the number of access episodes over a relevant period. Frequency two, or what they call frequency two, is actually the proportion of distinct online accesses to a relevant collection of resources. And then the interval, which is the proportion of the access time relative to the maximum access time. And the recency, which here measures the time lapse between the last access and the access end time. So we will modify a little bit this metric. As you can see, it's a multidimensional metric which actually provides a nuanced view of behavioral engagement. Wong and Chong here emphasize that predictive modeling could further enhance the reliability and the utility of this metric, which here forms the core of our investigation. So to further support our investigation, we also use the fact that Siemens and Baker highlight the value of clickstream data as a proxy for engagement. So this makes it really an ideal tool to investigate the reliability of the metric by examining its association with short-term or weekly behaviors of students. Here, behaviors are introduced as clickstream. So we will also talk a little bit about the effect of the module delivery mode. So the data we collected is over 3 years, where we have different delivery modes, and we have the chance to actually assess that on the metric. So we changed the metric that was proposed by Wong and Chong here to remove recency and add the diversity of resources. So we would only use the frequency, the immediacy, and the diversity, and then we call the engagement metric the IDF engagement metric, which will be simply the sum of all three variables. Of course, each dimension or each variable here can be weighted to reflect its relative importance and provide maybe a more flexible behavioral engagement across the course, but this is really not the scope of the work right now. So we define this measure across each chapter of a course to see the engagement per, to be able to actually evaluate engagement per chapter. So to get the cumulative engagement metric of all the year, what we do is basically just apply a weighted sum across all chapters. For the weight, we do use expert advice, and that's the educator advice. And this design, even though doesn't really reflect or is not fully statistical, we say it still reflects the depth and the breadth of the student online interactions. So the case study we apply the metric on is actually a first-year programming module at UCL. The module is compulsory for stats and math students, so it covers approximately 200 to 250 students, and we have 3 years data of such module across 3 delivery modes, so the online, the hybrid, and the face-to-face. The module incorporates a wide variety of activities. We have lecture notes in a flipped classroom model. We have videos, quizzes, forums, group work, and also external resources that are available. So hopefully this kind of case study will allow us to test the generalizability of the metric and the ability to capture meaningful variations in engagement over time and across the delivery modes. So we do apply the metric across the 3 delivery modes. The analysis reveals a slight variation in the engagement metric across this, which was expected. So this is the Box-Cox transformed metric, and it shows an engagement score that decreases across the different delivery modes. So a score of around 16 if it's online, 14 if it's hybrid, and 13 in person. So the focus here is really not to predict the engagement, which I repeat again, but to evaluate whether the metric reliably captures the behavioral nuances of each mode, which it's actually doing. So importantly, this really supports the use of the metric in a fixed mode educational setting, because we do expect that the online engagement decreases if we introduce in-person sessions into the course. So now what we do is to try and link the clickstream data with the metric. So we hope that will help us explore how the students interact with virtual learning engagement and assess whether this is reflected in the metric using some predictive modeling techniques. The data analyzed, the data we have from Moodle includes the timestamps of interactions to the nearest minutes. We have anonymous user IDs. We have the titles and categories of each resources accessed, the purpose and details of each click, and including the user ID and the resource ID. So we do some exploratory analysis first. And here is just an example of graph of student interactions across the 3 delivery methods. So this means across the 3 years. And we could see that there is it's not very strong, but there is still a positive correlation emerging across all the plots, indicating that there is association of higher engagement levels according to the metric with the increased VLE clicks. And the resource interaction as well. So we have here different resources, including the quizzes, the videos, the lecture notes, or the total clicks as in the first graph. We also could see that the influence of the delivery method here on these correlation varies. So we have between week 7 and week 21, we could see that there is a decrease in the blue points, which means that there is a decrease in the clicks from those who are attending the sessions in person. And then in some other instances, we could see that the plot could indicate independence between the predictor and the delivery method, such as the evenly distributed clicks in the lecture notes here in week 7. Some other instances suggest dependency. So we need a bit more investigation. And we will make use of some machine learning models to investigate whether we can find patterns between the click streams and the online metric. So here we have tried several models, like the Ridge, Lasso, ElasticNet. We have the generalized additive models, the reduced generalized additive models, PCR, the SVR with the linear or radial RBF kernel, and the random forests. So we could basically, just by looking at the RMSE or the R squared, we could see that the models that are capturing nonlinear relationships are performing better, which fully supports the literature. The full GAM, the SVR with an RBF kernel, so the radial SVR radial here, have comparable R squared means and spread. They will show a little bit of improvement compared to the linear models. But the best one performing is really the reduced GAM here, with a lowest mean of around 2. I think it's 1.9 exactly, if I remember well. And then we have a highest R squared value as well here. So this highlights actually the importance of feature selection in reducing the noise and improving the model accuracy. In the next graph, we assign the student engagement levels according to the quintiles of the student engagement metric. So we have very low up to very high, 5 classes of engagement according to the metric again. And the figure will display the final model's performance segmented by these engagement levels with mean residuals that indicate the average deviation of predictions from the observed value. So the results basically show that the model will tend to overestimate engagement for students in the lower quintiles and underestimate for those in the upper quintiles. So this is kind of a phenomenon that's known as regression to the mean. And it poses a bit of, it poses some challenges in accurately identifying the students at risk if we're using this metric, of course. But one thing to denote here is probably to have a look at the red bar, which, sorry, at the pink bar, which refers to the random forest model. The random forest model is actually having a consistent prediction or consistent error across all the engagement level, which is reducing, or particularly here, really reducing the extreme prediction error in this case. So this is what we will be investigating further, the random forests, which is the most consistent model, and the GAM, which is the best one. So we'll have a look at the variable importance for both of these models, which will reveal some insights into how engagement evolves over time. So the clicks here, in the x-axis we have the weeks, and in the y-axis we have the different activities we have available in the course. And we could see the darker the squares are, the more important the variable is. So the analysis here reveals a bit about these trends, mainly that the clicks in second term, so starting from here, will show highest importance, particularly around assessment weeks. And we have also a sustained relevance of clicks post-winter break, which means that the students are re-engaging again after the break. So one thing to know about the course here is that, interestingly, after the winter break, students will be working in groups rather than individually. But still, the engagement metric is still picking up some individual engagement with the virtual learning engagement, with the virtual learning environment as a critical predictor. So in total here, we have 54 predictors with a value that is less than 0.1, and then just few that are less than 0.01. We have 6 predictors in the random forest model, which we all keep in the model as well. So in both of them, we see that the clicks are consistently associated with the engagement, of course, and having a high score that's about, I think this is over 800 or so. Right. So then we assess as well the delivery modes as part of these predictive models. So there are 2 observations here with regards to the random forest and the reduced GAM model. So for the delivery mode variable had a predictor, had very low importance score in the random forest. It was still significant in the RGAM, but was not as significant in the random forest. Although it is significant in the RGAM model, it still has very low effect. So it was 0.3 for the hybrid mode and 0.6 for the in-person compared to the online delivery mode. So it's really inconclusive here to say that the delivery mode has an effect here. Right. So to conclude here, basically, this is a retrospective study, as you all can see, so that self-reported data for engagement is not really available, but it still demonstrates the potential of using clickstream data and predictive models to quantify and analyze student engagement. We did find that there is evidence that the weekly virtual learning environment interactions are associated with the metric, especially when using nonlinear machine learning models. The random forest and the ergam models are the best performing, and this again highlights the importance of feature selection. And then the delivery modes, while statistically significant, still have very minor practical effects compared to the other predictors. So thank you, everyone. I think this is the end, and I look forward to your questions.
Okay, yes, great. Thanks very much. If people would stick some questions into the Q&A, we're running a bit short of time, but there was a lot of interesting stuff there. So I've got a question. Have you written this up somewhere that we could perhaps follow up on it?
It's actually in, well, there is a preliminary paper in arXiv, which I could put the link for, but
Yeah,
we're still, yeah,
okay.
we're still working on it, and submit very soon.
Right, that's good. Yeah, if you could put the link into the chat at some point, that would be good because I mean I'd be particularly interested. I haven't heard this the phrase clickstream before, so that sounds like an interesting way of putting it. Because I know we have trouble with our VLEs, like we collect all this data and we can't work out what to do with it. Okay, so I think in the interest of time, I think we should move on, and people can put the questions in the Q&A still, and we can have them asked later. So thanks once again.